everyone. First of all, a sincere thank you to all those viewers for viewing my first ever YouTube video. This gave me more confidence and increased my interest. Welcoming you all to my second video. Welcoming to my channel Life Beyond the Sky. Now, as we have a family, the same way the planets, the star, and their satellites also have a family of their own, which we call the system. Our Earth lies in a system which we call the solar system. Such many systems togetherly form galaxies. So now let's get ready for the journey to the galaxies. The great galaxies. A galaxy is a family of stars, gas, and dust held together by gravity. Much of a galaxy is empty space with distances between each star that are hard to imagine. A guide to galaxies. Galaxies differ enormously in size, shape, and mass, but they do fall into basic pattern depending on their shape. There are four types of galaxies: spiral, irregular, barred spiral, and elliptical. Do you know? All the galaxies also rotate around themselves once every billion of years. Let's explore them. Different types of galaxies. First, spiral galaxy. They are the disc-shaped galaxies that spin slowly. They look a bit like whirlpools and are often have two arms that curl out from a central bulge. Our Milky Way is a spiral galaxy. Most of the galaxies which have been discovered yet are all spiral shaped. Interesting fact: the oldest spiral galaxy on file is BX442, which is 11 billion years old. This picture is of a grand spiral galaxy, UGC 2885. It has stars that are 10 times than the Milky Way. It's truly a galaxy of unusual size. Barrett spiral. Barrett spiral galaxies have arms that wind out from the ends of a central bar of star rather than from the core. Example, the Andromeda galaxy. Irregular galaxy. The name of this galaxy only tells us that they are the galaxies which do not have basic shape. They contain lots of gas and dust, and many are therefore active nurseries for the formation of new stars. For example, the Magellanic Clouds, which you can see in the picture. Elliptical galaxies. These are ball or egg-shaped galaxies and are largely made of old stars. They don't contain the gas clouds for the formation of new stars. Elliptical galaxies range in size from tens of millions to over 100 trillion stars. Example, the Maffei 1. Our galaxy, the Milky Way. Our solar system is a very tiny part of the gigantic galaxy, the Milky Way. It is a spiral-shaped galaxy. It contains 400 billion of stars. Now, why is it milky? Before the invention of telescope, people could not see the stars very clearly. They were blurred together in a hazy white streak. The ancient Greeks called this streak a river of milk. This is how our galaxy became known as the Milky Way. Do you know where are the oldest stars in the Milky Way situated? They lie towards the center of the Milky Way. Andromeda Galaxy. The neighboring galaxy to Milky Way is the Andromeda Galaxy, located about 2.5 million light years away. With about 1 trillion stars, It is the brightest galaxy seen. Its diameter is 260,000 light years. The major stars of Andromeda Galaxy are Andromeda, Alpha, Beta, and Gamma, all set out in a row. Do you know? Scientists believe that within coming few years, there is going to be a big collision between the Milky Way and Andromeda Galaxy. Collision of Milky Way and Andromeda. The monster collision between our Milky Way and fellow spiral galaxy Andromeda will occur about 4.5 billion years from now, according to the astronomers. Here I have a small video clip for you. This is how the collision will take place. The name given to the galaxy which is going to be formed after this collision is Milkomeda, the Triangulum Galaxy. The another neighboring galaxy is the barred spiral-shaped the Triangulum Galaxy. It is 2.73 million light-years away from our Earth. It is a shelter for 40 billion stars. It has a radius of 30,000 light-years. Located in a constellation that looks like triangle, it was discovered in 1764. The Triangulum Galaxy is the third largest member of the local group of galaxies, behind the Milky Way and the Andromeda. What is a galactic year? As we celebrate New Year on the midnight of 31st December and 1st Jan, the same way when our Sun orbits once around the center of the Milky Way, it is said to be called a galactic year. The time taken by the Sun to complete one galactic year is 225 to 250 million years. This is also called a cosmic year. We are moving at an average velocity of 8,28,000 km per hour. But even at that high rate, it still takes us about 230 million years to make one complete orbit around the Milky Way. The last time when our Earth made one complete galactic year, the dinosaurs were about to keep their foot on Earth. Here I have a video for you which will clearly explain how our Sun and the planets go around. This is how they complete the galactic year. The giant suckers. Now from the name only it clarifies. The suckers of space. Death of a star leads to the formation of black holes. They have such gravity that nothing in the surrounding space can escape, not even the light, which is said to be the fastest traveling theory in science. However, they are just a bit like whirlpools affecting just their area of space. You may be surprised to know that a giant black hole even lies in a galaxy, and not only in ours, but in every galaxy. How can we find black hole? When the whole space is black, even the black holes are blacks, then how do the scientists find them? Because of no light escaping out from the black hole, it is difficult to locate them. Scientists can find black hole because gas and dust falling into a hole rubs together and becomes incredibly hot. This gives off X-rays which the space telescopes detect. This picture is of a black hole's dusty shadow, a dust ring surrounding active galaxy IC 5063's central black hole. This creates a cosmic Silhouette tape. Will the suckers suck us? Black holes do not suck all the objects that would miss planet Earth, will still miss this black hole that's the same mass as planet Earth. There is no additional sucking force at all. They simply feed on gas and dust. The earlier ones ate a large quantity of matter and space, which made them more bigger and bigger in size. If asking about the matter inside, because of no escaping of light, we don't have any information about it. Death of a black hole. Hawking radiations reduce the mass and rotational energy of black holes. This phenomenon is known as black hole evaporation, because of which they do not get any mass and ultimately shrink. So, this was the journey of the galaxies. Hope you all enjoyed it. Thanks for watching.